be started the physics 5 number 3. This is the stage number 1. So let me introduce the jury. So I'm Su Jongwu from National Jai University. And the second jury is Chen Hongyi from National Taiwan Normal University. The third one is Mo Zhongyu from Tsinghua University. The fourth is Zhong Gongquan from the National Zhongshan University. The last one is Wen Junyan, also from the Dongwu Dashi. Yes, welcome. So each team have to introduce themselves. So please, from the reporter, okay. So please introduce your team.
My name is Zheng Chen, and our team is Wang Yang. My teammates' name is Lin Qingwei, Chen Xianyong, and Zhang Jiawen.
Okay, so the second one is for the opponent. Opponent is my heart, right?
My name is Cai Yilei, and we're from Yahahai. And this is Lin Pingyi, Ji Yaxing, Wang Yanqi, and Li Yuqian.
Thank you. So the next one is for the girl, please.
We are Team 4 from National Chongqing Senior High School and Captain Zhong Yixing, and they are my teammates Siru, Jiajing, Yizhen. Thank you.
Okay. So before the stage starts, I would like to remind all of you to we cannot using the internet, cannot be video, any recording. So everyone cannot stop in front of the projector to prevent the destroy. So now let's move on the first procedure 1. The opponent challenge the reporter for the problem. We have 1 minute.
We want to challenge problem number 11.
Number 11. Reset. Reset. Okay. So the fighter have to write their names on the blackboard. Yes. One student have to write their names on the blackboard.
不要等，我们可以先站，或者先找一
OK
点。
pose。Okay, let's move on to the presentation of the recorder. Ready? Please, you can start.
First of all, we need to know what is hysteresis. Streamline hysteresis refers to a phenomenon where the state of a system depends not only on its current conditions but also on its history. It also means that the response of the system to an external force or stimulus is affected by its past behavior. And you can look at this diagram. The cooling condition is always bigger than the releasing condition, but it's not like it is in a pattern from this it is in a pattern from this part. And that is our observation. We pull a mass vertically down to a certain place and release it to track the motion of the object. And the red point on screen to observe where it has hysteresis. And it is our diagram. It has two symmetrical spaces connected to the mass and lesion and add an adjustable force. And it is a red point on the screen. According to the chart below, we find out that the motion of the red point is not certainly damping oscillation, and we consider that the work of the hysteresis. And you can look at this chart. If it is only damping oscillation, the dot on the chart won't get over to the two black lines in the chart, but it get over to that. So we think the over point is the hysteresis. And then is our experimental setup. We use a force sensor connected with the mass to measure the force we apply. And here's our experiment video. And this is how we do the experiment. to regulate the direction of the electron flows. Here's the video. And that way the direction of the electron flows is being regulated. And here's our experimental procedure. First, we stretching and relieving springs to send displacement. Second, we recording the force gap between them. And third, we comparing the difference of force gap when we pull and relieve the spring movements. And this is our first experiment, level 1. We change the stretch twice to observe the force gap between pulling and relieving. And here's our results. And we found out that the hysteresis effect caused part of the system's energy to be transformed into heat energy. And we also observed that after the first stretch, the springs are extruded, cause the dislocation. So when we stretch it again, the amount of energy in it decreases. And you can look at this chart. At the first stretch, the force gap between pulling and relieving are obvious. When it comes to the second stretch, the third stretch, the force gap between them are not that apparent. And through this trial, we found out that pulling force is larger than the relieving force. But when the spring delta S is small, the hysteresis isn't apparent. We can look at this part. The reason here, the two lines are close to each other. And this is our second experiment on level 2. We changed the K-count type of the springs, and we also wanted to observe the force gap between pulling and releasing. And here's our data. We use two kinds of springs. One is the middle side with K constant 166.8 Newton per meter. And the other is the small size with K constant 275.6 Newton per meter. And we found that the hysteresis phenomenon is in a pattern when the K constant is small. We can compare these two charts. The gap between the pulling and relieving are more obvious in this chart. But when the K constant is smaller, the gap between them is in a pattern. And here's our conclusion. Through the whole experiment, we found that the hysteresis effect becomes less generative as we strain the spring more times. And second is the hysteresis effect to the spring becomes less generative as a spring contact. We can also call the CAD value. CAD value becomes movement. Okay, so that's all. Thank you for your listening.
Okay, so this one on the friction of the opponent to the reporter. Short questions in 2 minutes.
So, could you please go back to page 3? And can you explain why does the relieving condition and the boiling condition fit in the while it's short like from 0 to 0.2 cm? Yes.
Because we first got it and the reason of the spring is not always not obvious when we first got it.
Could you go to page 5?
externally damping oscillation. The sound will be out of these two backgrounds. Through our experiment data, we found out the dot is get over the background. So the thing like this phenomenon is the hysteresis.
Would you consider this as your error of your experiment? Maybe it could be an error of your experiment. Would you consider it an error?
Okay, the time is up. So now is the liberation time for the opponent. Okay, time for the opponent take to 4. Opponent. You have 4 minutes.
I'm running from Team and this is my as the problem statement stated, this experiment is going to investigate on the resulting motion of mass. So this is the brief summary of the report, and then they used an red point on spring to track. For experiment method, for experiment theory, they didn't provide any theory. So, and then is for the method, they used a sensor to detect use a force detector to detect the force on the spring. And for data analysis, they analyze the pulling force and the releasing force and drew them into a chart. So for conclusion, they said that hysteresis effect that's generated has more stretching times provided, and the effects that's generated has K decreases. So and the pros are they had some clear explanations and some clear charts, but for some improvements they had an unclear observation demonstration, so we couldn't actually observe what the experiment wants us to see. So, and then they have no theory for us to we to talk about, and they didn't have error bars in their charts, and we couldn't see the equations clearly. May I go to the discussion part?
Okay.
Could you go to page 6? Can you explain this video again?
Before the one sensor and for the sensing check and we do the motion of that just like the pull and stop and then we leave to a sensing space.
But as the problem statement stated, this experiment is talking about hysteresis, but your springs are they are compressed when you kind of poke the sensor into the probe. Is there anything that you want to get or in this experiment setup, did you release the springs?
This is great. In this way.
Like release it so it can vibrate and has some impact with hysteresis.
No, we didn't release it.
But if you didn't release it, when this pulls and then the vibration may go onto your hand and it will make the hysteresis you detected not that accurate. So when your hands are on the springs, when you pull the sensor, you wanted to detect the hysteresis on this spring, but when your hands are on it, the vibration may be disrupted by the springs.
Our hands are on the spring. There's a pin. Just stand on the spring.
Oh, yes, so the pins may disrupt the vibration of the springs. So how should you get the accurate vibration and that causes the hysteresis?
So in the compass statement,
page 5. It's page 3. Can you explain why this isn't 90?
Because we pull the sensor by hand, so it probably can consider as the experimental error.
But the problem statement stated that it is so what would you like to do if you wanted to stable this into a linear graph? So as you said, you use your hand to control the force. So that wouldn't be a continuous force as the properly stated.
So how will I improve this? Maybe we can use machine to pull the thing.
Did you do any experiment on the length of the string?
Length of the string. We didn't consider that as a
But you have two, in your later experiment, you have two, one is you have two springs, and you said that one is middle size and one is lower size. So did you do any investigation on those, so to have a result that separates them? Separate the results of the middle size spring and the large size spring. You did it and later on your experiment.
just consider about the K consequence.
I think that when you have two kinds of spring, maybe you can do some investigations on how the hysteresis will be interfered by the length of the spring. So, have you analyzed any energy loss on the experiment?
We consider the energy will lose in a way of this energy.
So, so did you measure it?
No, we didn't measure.
I think it would be better if you measure this and you can consider it into calculating the energy loss of your spring. Can you explain why this is hysteresis on this chart? Can you explain the hysteresis on this chart? Just why is this and hysteresis? That could be included into the result.
between the fluid and lubricant is the hysteresis phenomenon. And
never mind. So, what do you think is the most important factor of this experiment?
I think it's location.
No, I meant the what factor, like you did several experiments on different factors, so which one was the most influential?
You say the variables.
Yes.
The thing is great times because the hysteresis phenomenon is the obvious from this chart.
I think it's the mass that you added on into it's the force that you pull the spring because a different force could lead to different distances. Like you said in your previous research, you said that when the further your spring is pulled, the more distances you will get. So I think the force would be the most important factor. Did you consider any damping effects on this, on your experiment?
We didn't consider it.
What do you think is
Okay, time is up. Only we have 1 minute to summarize.
in our discussion, we discussed about what is the main factor of this experiment, and the reporter said that it's this dislocation. But I think that the most important factor is the force that is applied onto the spring. And although we talked about the whether if they consider the damping effects onto the springs, so they said no. But in my opinion, I think that damping effect is will be an important factor if it is considered in this experiment. And also we also talked about the length of springs. So they had 2 different sizes of springs, but they didn't have a result of comparing them.
Okay, time is. There's no other question of the viewer.
First, I want to ask that you said about hysteresis, and I want to ask that why can have hysteresis? Your theory, you have three rules of the hysteresis. Why is there hysteresis?
Why is it as the hysteresis?
Why does spring have a hysteresis?
Why does it produce hysteresis?
The question to the opponent, can you explain why the spring have a hysteresis?
It's because the previous force of the spring is still adding back, and but you are already applying a new force, so that would cause the spring to vibrate in an not in an irregular pattern. So that is the reason.
And the opponent, why the spring has a
Because the theory has too many variables and
Is the reason cause the spring hysteresis? That's the reason.
the reason.
Okay, next question. And you use the synchron force for your spring, and you measure your force is parallel the y-axis.
Yes, we use the triangles.
think what causes the hysteresis is the motion of light.
Motion and
The motion and force.
So, I think that's the electron force return.
okay. And do your spring have touched the wall?
No.
Okay. Do you spring the barrel the hooker the door?
Time is up. Now you have 2 minutes for preparation. Okay, so
Hello everyone, I'm Jia from Team Photon. Today I'm going to report the problem 11, spring histories. And here is the problem statement. Our main fault, the first point is the process of the spring, and the second is what is the histories. So here is the review of a reporter. The reporter didn't use the theory, but I said theory is very important because reporter didn't use the theory to explain the why spring have the hysteresis. And the experiment and setup part, the experiment change the variable is the strain height and Fourier force. And reporter used the force sensor, but I think the experiment cell is not very stable because the reporter only to control this angle and didn't control the force is parallel the y-axis. So I think it's very important because if the force is not parallel the y-axis, the elastic will increase and the force will decrease. And didn't think about the finance. So the data analyzed and the reporter is about the hysteresis effect. It's very good to explain the definition of the data well, but I think it didn't connect data with theory because about the why can have the hysteresis and lack of the aerobat. So here is review of our opponent. The short question, the opponent always is the focus on the setup, so indicate the defect of the setup. But I think it's too focused on the experiment setup, but I think it didn't mention about the reporter's lack of the theory and about the data. And the discussion, the opponent said about the cell and the data. I think very good to connect with the short question but didn't discard the trend of the data and didn't discard the main reason that caused the history effect and didn't discard about housing historicity. So, in a key discussion, the opponent said, do you analyze and loss? The reporter said no. And I think there are many points in the experiment that will affect the experiment results. And here, the opponent said which is the most affect factor because different forces will cause a different historicity. And reporter didn't explain the clear, and I agree with the opponent. And our question, and I asked do you think why the spring motion is historicity? The reporter said it's a false, and the opponent said it's motion and false, and I say it's motion and false. And our question, now do you think the false in the reporter is not parallel, is that will affect data? The opponent said yes, and I think that it will cause the error in the data because elective will change. And this is missing point. I think about the history effect is very important, and I think that history effect is because the force and accelerator, when the force increase, the accelerator didn't follow the force, so we'll have the hysteresis. Thank you for your mind.
Okay, so we'll report you have 2 minutes for conclusion.
So we discussed about the topic of the springs to races, and I'm going to ask the first answer and spring question for a longer fiction. And we said no because the first answer was surprised and here. And we also I'm going to also ask me what's the most important variable, and from the code, we think is after discussing with the opponent, we agree with on this idea of the motion of force. And that's all.
Okay. So it's time for the question of our jury. So any question, please.
Yeah, I'd like to know those 18. Do you think the setup of the reporter faithfully represent what the problem is asking? So do you think your setup, experimental setup, faithfully represent what is asking in the problem? So do you agree that your setup will agree with the statement as the problem is asking? For example, the problem asking two identical linear screen symmetrically to a mass in a V shape before applying just force, then apply the just force to the mass. All this statement is used experiment setup agree with this statement. You think so? Okay, what about
I don't think their experiment setup is agreed to the problem statement because in the statement they said that the force needs to be a continuous force, and they use their hands to control the force on the springs, and also their springs later repeats to observe the phenomenon of the distances, and also their setup isn't like there are many conditions that they didn't consider into calculating the results.
And I also think the reporter cell is not very right and didn't fit with the problem thing.
Questions? Please show the story goals for the recorder. Please. 4, 4, 4, 5, 5. Okay, once is for the corner. Please show 5, 5, 5, 6, and 6. Final. Please show 6, 6, 6, 6, 6. Okay, so now break time.
Yeah.
Okay, so we have about 10 minutes for
Actually,
free 1 day. 10 minutes.